bell for the end of the school day may have rung, but the learning doesn't end there. This is your geography revision session. We're covering Year 7, Module 1, Water on the Land. I'm Mr. S, and I'll be your revision tutor. Water on the Land is our module on the work of rivers, the different landforms they produce and the processes involved, as well as what happens when there's too much water on the land. We have 5 elements to look at, so let's start with drainage basins. A drainage basin is the area of land that is drained into one main river and its resulting little rivers that come off it. That can be represented on our diagram by this dotted red line. So this is the outline of our drainage basin. This dotted red line represents what's called the watershed, and that's the highest point in our drainage basin. If the water falls on this side, it's going to go down into this river eventually. If it falls on this side, it goes down into another river that's off the diagram. Now, there are a few features that we need to understand in order to look at how the water gets from where it starts all the way down to where it ends. So let's start with the start. The start of a river is called the source. And in our drainage basin, there are a lot of sources because there are a lot of rivers. Everywhere where we've got this thin blue line represents a source, the start of a river. Where a river ends, which is where the river meets the sea, is called the mouth. And you can see here that in this drainage basin there's only one mouth because it's the main river. Now, the main river, or the main river channel, is the largest river, and that's the one that you can see flowing along my red pointer all the way up to this source here. So that's the main river channel. However, there are smaller rivers that join, and these are called tributaries. So we have quite a few tributaries, the larger ones, but also you've got these smaller ones coming off on even the smaller ones. So tributaries have tributaries as well. It sounds a bit silly. Where two rivers meet, this is called a confluence. So here is a confluence. We've got this river and this river meeting, but it also happens here, 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 and even on the smaller streams, here, 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 and here. And then finally, we have something called a floodplain. And the floodplain is the flat area of land, particularly near the mouth, so around here, what would represent it as this lighter green around here. And the floodplain are the flat lands on either side of a river where they particularly overflow or flood because there's too much water in the river. Let's have a look at this in an example we can see. I've got a picture of a drainage basin in real life. You can see that it's got very high, tall peaks along here. And that is the edge of our drainage basin, the watershed. This dotted line around here is representing the peaks of these mountains. When rain falls, if it falls on this side of the mountain, it's going to go down into this stream at the bottom of this valley. If it falls on the other side of the mountain, it's going to go down the other side and into a different river, into a different drainage basin. So you can see when we're talking about a drainage basin, we're talking about a large area of land that's surrounded by high mountains or tall hills. And depending on what side of the hill or the mountain the rain falls on, depends on whether it goes into one drainage basin or another drainage basin. But how does the water get there? Well, let's have a look at the water cycle. And the water cycle is looking at the process that water goes through to get from the ground into the sky and then back to the ground again. And there are a lot of different routes that it can take. Let's start off by looking at where our biggest source of water comes from. We have the oceans or the seas. When the sun is beating down on the surface of our planet, it's producing a lot of heat, and that causes evaporation. And that's when water goes from being a liquid into a gas. It rises up along with the rising hot air into our atmosphere. And that's what's being represented by this dotted line. When it gets closer to the edge of our atmosphere, it's going to start to cool because it's getting closer to space. And that means that all of the water inside the air is going to start condensing. That means that all the little water particles start to get closer together and they start to condense, which forms clouds. You can see this happening in your own home. If you've ever put a kettle on on a cold day and noticed all the steam, that's evaporation. And then when that steam might come close to, say, a window or a wall, it starts to form that mist and that vapour on the window, and it makes it really cloudy. And that's condensation. And that's happening in our atmosphere. All those clouds that you can see up in the sky is water that is condensed to form clouds. Condensation, and you've got your clouds up here. Now, these clouds will continue to float there until they become too heavy. And they become too heavy when they collect lots of water. And they collect more water when it's colder. And you can see here, it's reached over to this part here, and you can see the word precipitation. And precipitation just means any water that falls from the sky, but it doesn't have to be as rain. It could be snow, it could be sleet, it could be hail. Lots of different ways that water falls from the sky, but it's all precipitation. And because it's so heavy now, that precipitation, that rain has fallen down towards the ground. We went from water in the ocean to water held as a gas and a vapour in the sky, and it's now fallen back down towards the ground. Now, when the water's on the ground, there's a few things that can happen. It can flow over the surface of the land, and that's called surface runoff. You can see that represented here. Now, it could soak into the ground, and if it was soaking into the ground, that's called infiltration. And then it can either travel through the ground as through flow and make its way to a river or back into the sea, or it could go even deeper and end up in the rocks, and that's called percolation, when it seeps deeper into the ground. Or if it was staying on the surface, it might get intercepted, which isn't represented on here. But interception is when the water is taken up by trees and plants, and it's stored inside the plants. And when that happens, the sun's heat can evaporate the water from the plants. But it's not called evaporation this time, it's called transpiration. It's sometimes also known as evapotranspiration, when water is evaporated from the leaves of vegetation. And if none of that's happened, so it's managed to avoid getting soaked into the ground through infiltration, it's managed to avoid being intercepted by the trees, then it will run as surface runoff until it reaches a river or back into the ocean. And that is our water cycle. It's a continuous cycle. There are lots of different routes, but it is a cycle nonetheless. It's a closed cycle. It continues to happen over and over again. And this is happening inside our drainage basin. You can imagine this is one side of it, so there's our tall mountain, and that rain's falling down, and it's going through our drainage basin into the rivers, the little tributaries, into the main river channel, and out towards the mouth. Next, let's actually have a look at what's happening in these rivers. Rivers are a huge source of energy. As that water's careering down from the source all the way towards the mouth, it's got a lot of energy to do different types of processes. And there are two main types that we're going to have a look at today. The first one are erosion, and the second one are transport. And when we say the word erosion, we mean that it's destroying. And by that we mean that there are ways in which the water and the things in the water can destroy sides of the rivers, the banks, and the beds. And the first one we're going to have a look at is called hydraulic action. And this uses a lot of energy. What's happening is, as the water's coming down, it's going to force any air in the water into cracks in the sides of the river channel. And when it does that, all that water's getting pushed further in, all the air's getting pushed further in, but the air's got nowhere to go. And what ends up happening is the air has to force the cracks to be bigger so that it can continue being pressed. So that's almost like a little explosion of air pushing and making these cracks even bigger. And that happens time and time and time again until these cracks become so big that parts of the river bed and the sides of the river start to break away and takes away these huge chunks of rock. The second one is called abrasion. And abrasion is when we get small stones and pebbles and bits of sand, and it's rubbed against the sides and the bottom of the river. It's sometimes called the sandpaper effect, because that's effectively what's happening. These little stones are rubbing against the sides, and it eventually starts to wear away and makes it deeper or wider over time. We then have solution. And solution is when the water in the river is a little too acidic. And that means that it's going to start dissolving some of the material. So it could start dissolving the sides of the rock that make up the river. It could start dissolving some of the pebbles inside the river, and it stores it as a solution, as chemicals inside the river. And then finally we have something called attrition. And it's not really represented very well by this diagram. But attrition is when we have two stones or several stones and pebbles and they get knocked against each other. And as they knock against each other, they start to chip away at the edges and make them smaller and smoother over time. So attrition doesn't attack the river itself, it attacks the pebbles and the stones that are being carried by the river. Next up, we're going to look at transport. And this is how all the stuff that the river's carrying is moved in the river. And there are 4 different ways. The first one, which requires the most energy, is called traction. And that's where big stones are rolled along the riverbed. So they don't get up into the river, they stay on the riverbed because these stones are quite heavy. And the river will push them along the riverbed and they roll as they go. Think of like a tractor rumbling along the bottom of the river. Next up, we have saltation. And saltation works with smaller pebbles and stones and it bounces them. So instead of rolling along the bottom, the water picks it up, but it's a little too heavy so it can't keep it in the water and it's got to drop it again. And then it'll pick it up and then drop it again and it'll continue on. So think of it a bit like bouncing or leapfrogging all the way along the river. Next up we have suspension. And this is with really fine bits of sand and clay that are really, really light and the water can pick them up and carry them in the water itself. So it doesn't touch the ground and it doesn't touch the sides, it just floats in the river. And then we have the last one, which is solution. Now you'll notice solution is actually an erosional process as well as being a transport process. And solution is exactly the same as the erosion. It's dissolved rocks from the river and it's now carrying them inside the river. So it might dissolve it further upstream and then in its solution state it's going to be carried all the way towards the sea. And those are our processes. And they form different landforms along the river, which we'll have a look at now. River landforms are features of the river that you can see if you went and visited any river in the UK or around the world. But the different features occur in different parts of the river. The first one we're going to look at are waterfalls. These happen near to the source, right up at the top, near the start of the river. And a waterfall is a drop in the river. You can see here that we've got the river travelling along here, and then all of a sudden it drops down and it will continue along. Now waterfalls occur when we have 2 bands of rock. We've got a really hard bit of rock here that's really, really hard to erode. And then we've got a bit underneath that's actually a lot softer. So the soft bit underneath is going to erode a lot quicker than the hard bit on top. So over time, what's happening here, you can see the second diagram, this water is starting to erode underneath here and it's creating what's called an undercut. When the water's flowing down into the lower part here, it's eroding underneath here and this is creating what's called a plunge pool because all this water is plunging into it. And all the bits of rock and debris are going to start swirling around and making this deeper and deeper and deeper. Now the problem is this hard bit of rock is going to be really heavy, but it's no longer got very much support underneath, which means eventually it's going to fall and drop down into the plunge pool, which creates more material for the abrasion to start wearing away at here, as well as the hydraulic action from the water pushing down on it as it comes down. And then eventually that's going to continue, and you can see over time this hard bit of rock is starting to move further and further and back, and this is called a retreat. The waterfall retreats, it moves back towards the source of the river over time as more and more rock is lost and eroded away. This leaves behind what's called a gorge, and that can be represented here. So let's say this here was our point of the waterfall where this dotted line is, and over time this waterfall has started to move further back. So now the waterfall is here, it was once here. And it leaves behind these straight-sided valleys on either side, or straight sides on either side, and this is a bit like a really straight-sided valley. And this is the gorge. And you can see a really good example of this if you've ever been to High Force in Teesdale, along the River Tees. And you can be at the bottom of the waterfall where all the rocks are, and you can see two huge sides of rock going all the way along the river valley, and that is the gorge. The second one we're going to look at are meanders, and these occur closer to the mouth of the river near the end. And a meander is a turn in the river, and there are lots of examples of this. One of the best known ones in our local area would be Durham. The cathedral and the castle are on top of the middle of a meander, so they're basically where this X is here. And you can see on my diagram two different colours. We've got this red and we've got this yellow. The red represents erosion, where the erosion's happening, and the yellow is where the deposition happens. And deposition is when we have material that's been dropped by the river. So over time, what you can see is when the river's on the turn, the outside bend, so that's here and here and here and here, are being eroded. And the reason for that is on our cross section, so if we drew a line through a river from one side to the other, you can see on X, which is on the inside bend, and Y, which is on the outside bend is really deeper. And that means that the water can travel a lot faster, which means it's got more energy. So on the outside bend, it's going to start eroding because it's going to crash into here and then make the turn. So it's going to start eroding here. But on the inside bend, it has to slow down to go around this corner because it's shallower and it doesn't have a lot of space to make the turn. If you ever try to take a corner on a bike on the inside, you know you have to put your brakes on to make the corner. But if you went on the outside of the bend, you could make this really wide sweeping turn really easy without slowing down. And the same process is happening in the river. As the river slows down on the inside bend, it loses energy, which means it can't carry all the things that it has been, and it'll have to dump them, deposit them. And therefore, it's going to put more material down here, like sand and silt. So land has been lost over here, but it's been gained over here. And you can see what's actually going to happen here. Over time, there's more erosion over here, but there's more deposition, more land being made here. And you can see that this land's extended out, but land has been lost over here. And it's happening on all sides. The result is, this bit here, which is called the neck of the meander, is become really narrow. And over time, this continues to happen until these 2 points meet. And they eventually form a new channel for the river, which is a lot straighter than it once was. So the meander has gone from being a real big bend with a huge loop to being one straight line with a little bit left over. And this is called an oxbow lake. It's no longer connected to the water and it'll eventually dry up. And this is the flow of a meander. Finally, we're going to have a look at what happens when there's too much water on the land. Back in 2012, there was a huge flooding event that hit the east coast of England and Scotland, which we call the Toon Monsoon or Thunder Thursday. We're studying this because it happened in our local area. Hebburn and Jarrow were very severely affected by the flooding that happened in 2012. You can see some examples of what happened here. We've got a lightning bolt that hit very close to the iconic Tyne Bridge. We've got metro stations that were completely flooded. In Newcastle, drains couldn't cope with all the water, and you can see it's actually fountaining out of the drains because there's so much coming out and people struggling to get home after a long commute. But why did Thunder Thursday happen? Well, it happened around in our summer as what this jet stream, which is this huge channel of air up in our upper atmosphere, and it sort of directs where our main weather patterns come from. And because the summer jet stream was over us, it was bringing us some storms. And because of that, we've had 2 inches of rain falling and the old drain systems just couldn't cope. The storm came over the Pennine Mountains as well, and as the came over the mountains, it's producing more rain, more than we would expect to get. The jet stream being in slightly the wrong place, the storm coming across the Pennines has created this storm, which was something that we weren't expecting at the time. And there were quite a few effects. We know that 500 homes were flooded, and were flooded for a substantial amount of time, meaning that people had to live in hotels for a while. It happened during rush hour on the commute home, which meant that a lot of drivers were actually stuck and had to abandon their cars and seek safety and walk home. And all of those three factors are what we'd call health related or people related, social. We can also look at it in terms of infrastructure. So that's the road networks, the power, the transportation and buildings. And you can see here that some roads were collapsed or were cut off because of flooding. The Tyne Tunnel was flooded and was closed. And the metro lines were flooded, meaning that people couldn't commute on the local transport. And it had a huge impact on our local economy. So that's the money, either through trade or through businesses. So you can see there, £8 million worth of damage was caused for the local councils to pay out to repair the damage. The Hoppins Fair was cancelled in Newcastle, and the Swan Pub in Heworth was flooded. And there are a lot of responses that have went on, but if we focus on just a few. Local residents who were flooded realised that there may be a chance that they would be flooded again in the future. So they started laying waterproof concrete as foundations, which meant that the water couldn't seep through the ground and into their house. And if it did flood in the future, they'd want to make sure that their houses didn't need as much work doing to put them right again in the future. So things like wall plugs, which are usually close to the ground on the ground floor, were moved up so they were about 1 metre off the ground, so that if their homes did flood, they wouldn't need to repair all of their electricals as well. In Morpeth, they put up flood defences. They put up flood walls, flood gates. They tried to put these big reservoirs in, which meant that the water would be contained in an area instead of flooding out into houses and into shops. And £100 million has been spent on flood defences throughout the region. And you can even see an example of that at school. If you look out onto the school playing field, you'll notice that there is a huge ditch that's been built just at the edge of the playing field going onto the yard. And that is there to channel any water that reaches the school field into that channel, and it goes into what's called a culvert, which is an underground pipe, and it goes under the road and goes behind the Mill Tavern. And there you've got this huge big area of open fields, and they've designed it so that that area is allowed to flood. It's going to store all the rainwater and slowly seep into the ground over time. And they've done that for loads of areas around Hebburn, and it all funnels into the park behind Mill Lane, which is better than actually flooding the houses of the area. That's it for today, but don't forget to complete the home study questions to test yourself. Goodbye.